Mr. Squirrel up in that tree is really making a lot of noise today. Welcome back to the show, everybody. If this is your first time tuning in, I am Squatch. We are working on restoring a 1936 Caterpillar RD-6. And if you're new here, feel free to check out the playlist of the project that I have compiled on the channel here. All the prior episodes are in order from the start to the most recent for a quick and easy way to get caught up on everything that's happened to this point. I think we're on episode number 21 here. I'll have to look back and see. But yeah, it is also deer hunting season, hence the orange that I will be wearing anytime I'm outside. It'll be hunting season for the next couple of weeks, so you'll probably be seeing more of this. And to refresh everybody on the lineup, under the green cover is the RD-6 that we are restoring. This is a parts tractor for that project, as well as this one. Old Frosty here gets smaller every time I bring you all back. Yeah, we removed track frames and whatnot yesterday. We're looking at old Stovepipe again today, though. Stovepipe is just about a completely empty tub, and I have a pretty cool plan for this empty tub. We won't get into that right now, though, but we have another puller episode to get through today because I need to remove the dead axles from each side of the tub. And I think we will begin with an RD-6 FAQ today because we've been doing a lot of puller work lately. We have a lot more to do on this episode, and there have been a lot of really good questions in the comments section regarding pullers. Of the two questions I will use today, the first one was left by Rammy630 under the prior episode where we built the first pulling adapter. And he says, very nice. Where can I get that Porta-Power unit? Could this be adapted to press out track pins? Thanks. And the second question was left by @It'sLukeOfficial1508. He says, impressed every time. Don't know much about machining, but love the results. But what would be the correct Caterpillar way to do this procedure? Was there special tooling available? Okay, so for the first question, I've put most of my hydraulic puller tooling out on the bench. The hollow ram he was asking about is my 30-ton right here. These are all made by OTC, that is Owatonna Tool Company. And you can go on the OTC website and browse through all of the different size rams, the different pulling attachments that are made to go with them. And then you can also find distributors where you can buy these OTC products. They're even widely available online like Amazon, Zorro, distributors like that. They're pretty easy to find. And the reason I refer to these as hollow rams is because they all have an open center hole that passes all the way through for attachments and adapters like, say, this forcing screw, things like that. So he was asking about this 30-ton hollow ram cylinder that we saw in the last episode, wondering if it can be used for track work, turning pins and bushings. That's a yes and a no at the same time. Yes, in that you have the modularity with these to do pretty much whatever you want. No, though, because 30 tons is not going to do it. You're going to need greater capacity. This is not going to be strong enough for the majority of track pins out there. Several years ago, I actually built my own track press on the channel here, and I highly recommend you go back and watch those track press episodes, and I've even thrown links to them in the description below. That's going to be the best way to get all caught up on the hows and the whys, but this is the cylinder I used for my track work. It is a 50-ton capacity, and even on D2 tracks, which are small, I was maxing this out, trying to press things apart on several occasions. There was probably half a dozen links where it took all 50 tons and heat just to get things moving. So if I ever built another track press, I would say a 60-ton would be my new minimum ram size, or even larger. So why all OTC? This is not a commercial. I've purchased every one of these bits a piece at a time throughout the years as I've been able to, and I'm still adding on. But I was familiar with the brand. I grew up using OTC, high quality, lifetime warranty, but the biggest factor for me, they engineer systems, puller systems around the rams. So every one of these puller kits is sized to work with the rams, all right? So this little 17.5-ton kit is the first one I started out with. Then a couple years ago, when I was working on 5J1113, the D2, I branched up into the 30-ton, and I also bought the 50-ton when I built the track press. And I've been adding pullers to them since. We now have the crossbar puller for the 30, which you saw me use last time with our adapter that we built. We can also turn these pull legs into pusher legs by threading these pusher feet on them, or they can attach into the bearing splitter, which is sized for the 30. I recently picked up this inside bearing race puller for RD-6 work. This is sized for the 30. The adapter here threads right onto the forcing screw, or you can take the adapter out and thread the bar right onto the smaller 17.5 ton screw. See what I'm saying? They make systems that work very well with one another. The modularity really increases capability. A couple years ago, I picked up the big 3-bar or 3-jaw Grip-O-Matic puller for the 30, and I've actually used this on the stovepipe Diesel 40. I pulled both the sprockets with the 30-ton setup, and you have to suspend this from the tractor when you're using it. You're looking at some considerable weight. And stovepipe Diesel 40, none of that stuff was very tight, and it was still about all this 30-ton could do to pull it. So about 6 weeks ago, I ordered the 3-jaw puller for the 50-ton. We're still waiting on that to show up, but I'm pretty sure I'm going to have to upgrade and be using 50 tons to pull the rest of those sprockets. And on the topic of everything working well with one another, the hand pump works on all of these rams. And they even put quadrants on the gauge for the 17.5, the 30, and the 50 ton with the tonnage that you're pulling at what pressure. So it's just a really good system. And they get you in the door through quality. They keep you there through just plain usefulness. And now the other comment, what was the Caterpillar factory set up for doing all of this hydraulic pressing? The Caterpillar Service Tools Manual is the go-to for that. And we have the 6F25 Caterpillar Service Press, and it's just an older version of all of the hollow rams that I'm using now. It's a hydraulic cylinder that is joined with a hose to a hand pump. The hand pump runs off of the same 0 to 10,000 psi max scale that all the modern hollow rams do. And on the following page are the service press attachments. Anything from the threaded couplings to grab onto the different components, to large spacers, to pull rods, to pusher bars, to accomplish anything from pulling sprockets to doing track work, and even the dead axle removal that we're working on today. Now, this Caterpillar setup was a pretty slick system. You had a smaller adapter that threaded onto the hydraulic cylinder piston. That smaller adapter was cross-drilled with a hole right through its middle. Then a larger adapter would thread onto whatever piece it was you were trying to move. That larger adapter also had a hole cross-drilled through its middle. Once both adapters were in place, the smaller ram adapter slid inside of the larger component adapter, and a single cross pin passed through both of them and joined the whole assembly together. So, in our scenario, pulling these dead axles today, our best approach is going to be replicating the original Caterpillar adapter system as best as possible. Now, the dead axles have threads on the end. These are 1.5 by 12 thread pitch. We're starting with this 1.5 by 12 deep coupling nut. So this is the piece that will attach to the end of the dead axle. So there's that. Our ram coupling adapter now will consist of this heavy threaded rod, this heavy nut. Both of these are 1 5/8 by 5 1/2 thread, which match the inside of the big 50-ton ram. I'm using the 50-ton ram simply because these components are already so close to being the same size. It just makes the setup easier. I think the 30 would pull those axles. I know we can with the 50. The rest of the ram coupling then will be made out of this very heavy wall steel tube. All right. And because I am not equipped to cut internal threads of this size or that depth, the easiest way to do it for me is to turn down the outside of the nut, turn out the inside of the tube, embed the nut in the tube, cross-drill the tube and that coupler, and we've joined the ram to the dead axle. That's the plan. So I think we'll start with the ram coupling adapter first, and then we'll make this fit inside of the tube. So we begin with turning the hex portion of the nut down and making the outside round. Going from hex to round always rattles a lathe pretty hard, so we're doing that on the little China lathe here. I don't feel so bad beating this one up. It's getting a little bit smoother now, more round. Now we're nice and round and getting it down to size. And we also want to face off the end so we're nice and square. And finally, I need to pull a generous chamfer on this outer corner. That should do. Alright, here's where we see if the bandsaw is going to get all the way through before... Nope, we just bottomed out on the top. Okay. Need to turn the piece a little bit or figure out if we can finish it off by hand. Here is going to be the sleeve portion that the nut that we just turned down will end up going into. My bandsaw is a bit small, but I'm still thankful for getting me that far anyway. There it is. Okay, I've got our heavy wall tube in the south bend, and I'm hoping I can do the machining that I want to do without having to support this. We're just hanging out of the chuck. I think we'll be all right. What I want to do is face off the end, and then we need to bore the inside out for that nut to drop down in. We don't have to do anything to the outside at all. We can leave that completely rough. So let me see if I can face this, and then I'll decide whether or not I need some more support. Yeah, good. I could feel a little bit of vibration, but yeah, we're just fine. So next step, take out the center with the boring bar, and I've got the rough stuff cut out. We are all down to clean material now. And just having a look at things, it's actually leaving a pretty good finish considering it sounds horrible. I have a rather small diameter bar and it's stuck out there quite a ways, but it seems to be doing the job. I might mute the volume for you all though, or turn it down because it's loud. Okay, I think we're done on the inside. You can see the step back in there where the nut is going to bottom. That was quite a few passes with this small bar, and I didn't show most of it because it was pretty hard to listen to. But I've been in with the inside bore gauge, done all my checks. We are 2 1/4 diameter on the inside right now. That's exactly where I wanted to be. So I'll knock these square corners off next. So the main sleeve is done. Happy with that. Now, the threaded nut portion that goes inside. Turns out I'm not so happy with this. I didn't put this in the chuck properly when I turned it down, and I didn't realize it until I threaded it onto the heavy rod. There's a lot of run out in that. It might be hard to see on camera, but it's threading on and kind of walking like that. So I need to redo this. Yeah, I didn't take the time to do it properly the first time around, so now I get to take the time to do it again. That's all right though. I have more. All right, hopefully round 2 will be better. Already looks a lot better. Let's do a test fit on the threads, see how this one spins. And I can already say it is much better. I don't see any wobble in that at all. Let's see how it tightens against the face of the ram. Yeah, nice and square. That's what we should have done the first time. That's what I should have done the first time. Put it that way. So, okay. Finished with this piece, enough to put it inside the main sleeve. So now I have the main sleeve viced into the bridge port. I need to drill this hole. And then tap it for 1/4 by 20 threads. A little set screw goes into the hole, and now we give it the threads. I made this sleeve to be a light slip fit. I didn't want to make it permanent, and I can show you the reason for it once we get it in. It is a very close tolerance. You have to dance it in. There we are, just right for it to slide down. But the set screw will lock the threaded sleeve in position so that we can put this onto the ram without it spinning. And the reason why I made this center so easily replaceable, in case I need to put something else in there to fit this heavy sleeve onto something else. Once you get used to having hollow rams, you just about look at everything and think, how could I hook that up to it? So as long as I was taking the time to make this heavy sleeve, let's make it as useful as we can, future-proof it. We've got a good 1¼ inch material behind the threads to help with the pull. So to fit up to the ram. We aren't done with this piece yet. We're just making sure that it's going to do everything we need it to do so far. Yeah, it looks good. So now that we know we can fit that to the cylinder, we take our coupling nut and we turn, I'd say the first 2 inches down to about right here so that it's round and appropriately sized to fit into this sleeve. More rumbly cutting, but we don't have to take too much off the outside of this one. I haven't measured yet, but we finally rounded out. That should put us pretty close. All right. Plenty of click there. You don't want this to be super tight because that is going to make assembling it a lot easier. Yeah, we are as far as we need to go there. So now we cross drill each adapter for the pin that will join them together. And that finishes up both of the threaded adapters, ram connection, dead axle connection, and high grade cross pin will go through the holes, join both pieces together. 50-ton ram is prepped. He is in battle mode. I've got the end plate on for pushing and the long high grade threaded rod in place. So we'll do one more test assembly here. You all have already seen this part, but we go just until the threaded rod is flush with the inside of that adapter. And this one goes in like that. You line up the holes, pin goes through. We are ready to pull. So we have the ram hooked to the dead axle here. We need a push tube. I just cut that this morning. So here we are. That should be the right length to surround the dead axle, so that we can push on the case right here, the other end of the tube, push on the ram right here, and as the piston starts to drift out of the ram, it pulls like that. So the tube will surround all of that stuff and push right on the end of the ram, okay? We don't know if that's gonna be thick enough to hold up. We will find out, but I used this little scrap piece here to, or I saved it, I should say, to give you all an idea. Once that tube is around our adapters, it will cage the cross pin in, so that cross pin cannot fall out once the tube is over it. So it should hold itself all together. Let's just see if our design is going to hold up to the tonnage required. Setup time. Just join these two adapters real quick. There, freeze up my hands. So we've only got about 10 threads. Oh, I say only, 10 should be enough on our dead axle adapter, because down here where they're really mashed, those are worn farther than what I can clean up with the little thread file. We'll just give it a try with what we got. Pusher tube. And now the ram. Tractor is at the ready to suspend it as well. I'm going to go until I can feel the coupling bottom out. That way I know I have full thread engagement. Yep, right there. Back her off a little bit. Spin the ram on the rod. Set my clearance. Okay, I like it like that. And just making sure the push tube is well centered so everything looks good and square. Hopefully the strap will catch the ram if something catastrophic wants to happen. Hand pump is in place, and I'm also filming the catch nut. The dead axles have retaining nuts on the inside, one right here and one right there. I've got both of these backed off so that there's, yeah, you see the lock is loose. There's clearance there, and when the taper lets go, that nut will keep everything from blasting completely out of the case, unless we have a catastrophic failure with an adapter, in which case I'm at least hooked up to the piece that I really love. So, all right, let's see if it works. It's about 7 tons. 12. Oh, I heard a little bit of a noise. Catch nut is not tight yet. I think it let go at about 15 ton. It's about 7 tons. 12. Oh, I heard a little bit of a noise. Catch nut is not tight yet. I think it let go at about 15 ton. Okay, here's something else that I hadn't anticipated. As long as I have the puller attached, I'm still going with it. And I've pulled it out, you can see, that far. And I didn't anticipate this straight bore having so much drag because it's rusty. That's not a taper there, it just goes inside of a hole, but it's still pulling with a couple tons of force, even though we've disengaged the taper. And I only built probably about 1.5 inches worth of pull travel into my adapters before they bottom against the ram. I'm just going to keep pulling until I start feeling resistance, and we'll at least get it that far out anyway with hydraulic pressure. Okay, there we are. That's as far as we get it to pull, but it was starting to drift pretty easy there. So I'll detach here, see if we can get the rest of that out, or get that out the rest of the way by hand. Yeah, not the end of the world. We had to employ the handyman to pull that the rest of the way out of that smooth bore, but yeah, if I was going to build one of these again, I would need a longer tube, because your push tube decides how far away from the end of the axle your ram is, your cylinder. So I'm not going to build a longer tube at this point. I think we got it just by working the old way, old school way, how I used to do it, handyman. Okay, there's our taper right there that we had to detach. And in here, right down on the end, that's where we were dragging in the straight bore. So, all right, live and learn. All right, ready to pull the other side. I have to put the bucket here though, so that I can block the sun glare from the holding nut cam. Y'all get a better view that way. All right, rolling on all points. Yeah, earlier I suspected This dead axle was bent. I think I mentioned it in a prior episode. When I start stacking square components on there and see how it all shakes out, this axle's definitely bent. It's tweaked back just a little bit. So we'll just see how it pulls. I have just enough tension on everything where it kind of flexed back straight. Okay, about 12 ton. All right, 15. Okay, about 12 ton. All right, 15. About like the other one, except now I know I need to keep pushing it all the way until I run out of ram travel. And that is one bad, worn dead axle and bent. No saving this one. Well, I guess I'm happy with the puller setup. It pulls dead axles. Once again, I think old stovepipe is a little bit on the light side. The other tractors may be a little bit more of a job for it, but yeah, learn from my mistakes, everybody. If you're going to do this, make your pull tube plenty long enough so that you have enough ram travel to get those dead axles completely out, even that straight part on the end. But still, this one did what we needed it to do, so calling it a success. And a few people have jokingly told me in the comment section that I overbuild everything that I make. Well, I want to show you something. When I was doing the research to build these tools, I found this one on eBay. Okay, this is just the blue part. This is the authentic Caterpillar version from that 6F25 service press. And I picked this one up for about $100, and I couldn't even afford the steel blank to make it for that. But this is the 5F9879 inch and 3/4 by 12 thread. And what this is for on RD-6 is grabbing onto the threads on the end of these final drive pinions and pressing the flanges back onto them. And it also grabs onto the bevel shaft for pressing the steering clutches back on. So that made me happy. One less that I have to build, but compare it to the biggest piece we made here. Cat stuff is beefier, and I did a 5/8 pin on this one. This is a 1 inch, and you can tell it's done some pulling in its day. But yeah, I was really happy to find that. That makes life a lot easier. And yes, we would love to find one of the original 6F25 service press kits in Cosmoline with all the adapters, never been used. Can you imagine how much easier life would be on us old Caterpillar guys if they were just still available like that? But, well, I hope you all enjoyed this episode. I've spent the last 2 weeks trying to build my way into making the next couple of episodes that are on the docket now to continue with the disassembly of the Narrow RD-6, but it's always a lot of work, and this is kind of the mode I was in during the 5J1113 D2 rebuild, where I had to kind of build my tooling and set myself up as I went through. It takes so much extra time. Now that I've got all the D2 tools built, y'all have been there, done that, seen that. Now we're doing the same process on the RD-6, but I'm happy with how things are coming together. And this episode has been pretty heavy on pullers because, as you've seen by now, anything you do on these old Caterpillars, pullers are so necessary. They're mandatory. And when you start getting into the bigger machines, even this RD-6, which I consider still mid-size, You just need to have that pulling capacity if you're going to do much of anything at all. So, okay, I think I'll let you all go. We still had fun here today, I think. So hope to see y'all back next time. We'll probably be back on the narrow RD-6, continue with that teardown. So see y'all then. Thanks again, everybody.